So with statement of hypothesis, as I indicated earlier, we have two types. You already know. We have null hypothesis and alternative hypothesis. All right, so normally we represent the null with HO symbol, then alternative H1 symbol. And we normally say that the alternative hypothesis is the researcher's hypothesis, meaning that, and I know right currently you know what a hypothesis is all about. So it means that with the alternative hypothesis, you can find it within the question given to you, because in the question, some predictions have been made, and that will be your alternative hypothesis. So when you check the question, this thing was posed. Is there a significant difference in performance between males and females? You know, we have what? Males and females, and we're comparing whether we will have any differences on performance. So a question has been posed that, is there any difference between males and females in terms of performance? So it means that is what? The alternative hypothesis. And in most situations, alternative hypothesis, you are supposed to make it in a statement form. So this is how you indicate. There is a significant difference between males and females performance in inferential statistics. So you are telling us that there's a difference in the two groups, or there's a difference in statistics between the two groups. Okay, Bernice, please go ahead.
Sir.
Yep.
Sir, please, you said something that the alternative hypothesis is in the question.
Yes, Bernice, because the alternative hypothesis is the researcher's hypothesis. So it means the researcher definitely posed a question, or they made some predictions. So within the question, a prediction will be made, and that prediction is what? Is the alternative hypothesis.
Oh, okay.
Okay. Then
okay.
The null hypothesis will be the opposite of the alternative hypothesis. But with the null hypothesis, you wouldn't find it in the question. You wouldn't find the null hypothesis in the question. But so long as you have the alternative hypothesis, it shouldn't be an issue, you indicating the null hypothesis, because as I said, it is the opposite of the alternative. So if the alternative is saying there's a difference, then it means the null hypothesis will be that there's no difference. All right. So.
Hello, sir.
Yep, Ophelia.
Sir, please, I want, please, is it possible you could zoom the question for us for a bit?
I should zoom it.
Could zoom it a bit for me.
Is it better now?
I can't see it clearly.
Is it better now?
Yes, please. Yes.
Perfect.
Yes, thank you so much.
You're welcome. You're welcome. Okay. So this type of hypothesis, especially the alternative, when you see that they've indicated there's a difference, it means they haven't told us whether males will be higher or lower in performance than females. They just indicated, oh, there would be a difference between the two groups. I hope you get it. They didn't specifically tell us that, oh, one group will be higher or lower. They just said there'll be a difference. So when that happens, when you see a hypothesis like this, we call this type of hypothesis non-directional hypothesis, or sometimes called two-tailed hypothesis. So I'm repeating, when they don't tell you the direction between the two groups. They don't tell you that, okay, one is positive or one is higher or one is lower or whatever. Then it means they just indicate there's a difference or there's, who is that? Mercy, please mute yourself. Who is that? I've been muting all of you, but you mute. Oh, who is that? Wow. Okay, so if they don't indicate that, oh, one is higher, one is lower, one is positive, one is negative, and all that, then it means they just tell you, oh, there's a difference or there's an influence between the two groups. It means it is non-directional or two-tailed because they didn't specifically tell us which one is better than the other. So we call this type of hypothesis two-tailed or non-directional hypothesis. You remember I said when it comes to inferential statistics, we transform it into a normal curve distribution. So there's a reason as to why we call it two-tailed. Let me draw the normal curve. When you draw the normal curve, this side is 0. It means that scores around this side should be negative, then scores around this side should be positive. So they didn't specifically tell us whether males were higher or lower than the other. So for if they have said males will be higher than females, then it means that we expect our scores to be positive around this side. So it means it should be one-tailed. But here comes they said there's a difference. So we don't know whether males were higher or males were lower. So it means at the moment our scores could fall around either the negative side or the positive side. We don't know for sure. So that's why we call it two-tailed or non-directional hypothesis, because we don't know which one is positive or which one is negative. That's the groups. Okay. And under step 2, you don't just state the hypothesis. You are supposed to represent it in symbol. You are supposed to represent it in symbol. So under HO, we are saying there's no difference. So when we say there's no difference, then it means that what we are saying is that the two groups, males and females, they are what? The same. This is English. We are saying there's no difference between two groups, meaning that we expect them to be what? To be equal. So that's why we are saying mu1. And I believe you know this symbol. This one is the population mean. So population mean 1 is for males. Then population mean 2 is for females. So we are saying that population mean 1, which is males, will be equal to population mean 2 because we indicated that there's no difference. So we expect them to be the same. Then under H1, we indicated that there will be a difference. So what we are saying is that there's no way population mean 1 and population mean 2 will be what? Equal. So it means mean 1 is not equal to mean 2. All right. Within the question, it can be posed in such a way that it wouldn't be non-directional, but this time around, it could be what? Directional. They can pose the question in such a way that the question will be, or the hypothesis will be directional or one-tailed. So they could have posed it like, okay, males will perform better in statistics than females. They could have posed it in this form. Had they posed it in this form, then it means that they've what? They've indicated the direction, because we are comparing two groups, males and females. And here comes the case, they've indicated that males will be higher than what? Than females. So it means they've indicated the direction they expect the hypothesis to be. So it means our alternative hypothesis will be what? Males will perform better than females in inferential statistics. That would have been our alternative hypothesis. Then this time around, our symbol wouldn't be the symbol where we indicated not equal to, but rather the symbol this time around will be that we are saying males will perform better. So it means males will be what? Will be greater than females, because mean 1 is for males. So it means mean 1 will be greater than mean 2. That will be for H1. Then under HO, you remember I said HO is what? Is the opposite of H1. So it means the first opposite we can see is that males will perform worse than females in inferential statistics. By using this symbol. Since we are saying males will perform worse, then it means that males will be less than females. That'll be for HO. So under HO, you get two hypotheses, because since H1 we indicated males will be better, that means greater than. We want all possible or opposite of what? For HO. So the first opposite could be that, oh, males will perform worse, which is less than, or in a calculation, it could be that the two groups will be the same. So it means males and females, they will be the same. That's also another opposite. So it means you indicate this one too. There is no significant difference. That would also fall under HO. So it means that what this implies is that anytime your hypothesis is non-directional, you are supposed to state one hypothesis for H1 and one hypothesis for HO. But in situations whereby your hypothesis is directional, that's one tilde, you are supposed to state one hypothesis for H1 and two hypotheses for HO. All right, so please, any question?
Hello, sir.
Okay, Olali.
So will it not be better if you say less or equal to instead of stating the two hypotheses?
I totally get it. You can combine the two, but you know, I want things to be clear for everyone. Not everyone would understand it if I comprehend. Oh, sorry,
Okay,
if I compress them.
Thank you.
All right. Okay. So any other question? All right. Then that'll be all when it comes to step 2. So the next one is step 3.
Hello, sir, please, I have a question.
All right, Regina, go ahead.
Yes. Sir, please, you said when it is directional, the null hypothesis will be, you said 2 of the null hypothesis.
Yes, that's
And
what I
when
said.
it's non-directional, I don't really get that part well.
So who can explain? Who can explain for Regina to understand this? Hello, someone should explain. Hey.
Regina, can you come with the questions again?
She wants to find out, you know, I indicated that when it is directional, you're supposed to state 2 hypotheses for the null hypothesis, right?
Yes.
So she wants to find, yes.
Yeah, my explanation is since this one is performing poorer, and the alternative hypothesis only states is performing greater, so the poorer can be either equal to the mean or less. Less. That is my understanding. And the alternative will always be greater.
The thing is, I indicated that within the question, it could be that, okay, they stated it like this. Instead of they saying, is there a significant difference? They can pose it like this. Males will perform better in statistics than females. So I said with the alternative hypothesis, always you get it in a question because a prediction has been made. So let's say this is a prediction that was made in a question. So this statement will be for alternative hypothesis. Fine. With the null hypothesis, I indicated that it is the opposite of the alternative. So when you check this statement, its opposite could be what? Males performing worse, right? So that will be for the null hypothesis. Another opposite that we can find or we can generate from this question is that, or from this statement is that when it comes to males and females, they will be the same or they'll be equal. So that's what we've indicated. So it means when the question is directional, you can see that this hypothesis is directional because they've indicated that one will be higher than the other. So it means anytime you see that your alternative hypothesis is directional or one-tiled, always state 2 different null hypotheses. Because from this statement, we can generate 2 different null hypotheses. The first one will be we emphasizing that males perform worse. Then the second one is we also emphasizing that, oh, there's no significant difference between the 2 groups. Okay, so that's all when it comes to statement of hypothesis. So the next one is decision rule under step 3. Under step 3, we have decision rule. Under decision rule, for you to do anything, there are 3 key things you need to know. The first one is find out whether your hypothesis is directional or non-directional. So you need to find out from the question whether the alternative hypothesis was stated in a directional form or non-directional. And from this question, let me clean these things before it confuses anyone. The question that we are solving, okay, so per the question that we are solving, our hypothesis was what? Was stated in a non-directional form. So it means the decision, we will select this one, non-directional. Then the next thing you're supposed to know is the level of significance. And by now you should know what the level of significance is all about. So find out within the question, did they indicate the level of significance. In most situations, the level of significance should either be 0.05 or 0.01. Within the question, did they indicate the level of significance anywhere? If they were silent, they didn't indicate, always assume that the level of significance is 0.05. This is really, really essential. It's really, really critical. I'm emphasizing on it. Whenever you read a question and you find out that, oh, they didn't indicate the level of significance, or they were silent when it comes to the level of significance, assume that it is 0.05. So this question, for instance, they didn't tell us the level of significance, so we are assuming that it is 0.05. Then the next thing we are supposed to generate is degree of freedom, which is represented with the symbol DF. The degree of freedom for independent t-tests with this no formula or whatsoever we're giving to you. You wouldn't find it in the formula book when it comes to degree of freedoms for the various tests that we'll be using. So you have to know the degree of freedoms for each test. So let me pose this question. What's the degree of freedom for one sample t-test? What's the degree of freedom for one sample t-test? Interesting.
One sample t-test.
There is n-1.
Yeah, so the degree of freedom for one sample t-test is n-1. But with independent t-tests, the degree of freedom is n1 plus n2 minus 2. So that's the formula, where n1 represents the sample size for group 1, n2 sample size for group 2. So when you check the question, you could see that they indicated that group 1, that's males, we have what? 12 people. Then group 2, females, we have 10. So it means our degree of freedom will be 12 plus 10 minus 2, which is equal to 20. So it means our degree of freedom is 20. All right, so please, any questions so far? Any questions so far?
Sir, please go back. Degree of freedom.
Can you please go over the formula for the degree of freedom? Yes, degree of freedom, please. Thank you.
What do you want me to go over? Because you already have it. N1 plus N2 minus 2. N1 is for the total number of people within group 1. N2 is for the total number of people within group 2. Right?
You mentioned directional and non-directional. So that's what we want to get.
You already know I've highlighted on directional and non-directional when I was talking about statement of hypothesis. So I said for us to say that a hypothesis is directional or non-directional, it solely depends on the alternative hypothesis, the prediction that was made in the question. So you go back and check the prediction that was made. Was it in a directional form or non-directional form? And we were able to deduce that. This prediction is what? It's non-directional, because they didn't tell us whether males will be higher or better or worse than the other group. They just said there will be a difference. So it means it is two-tailed or non-directional. So that's why we selected non-directional. And you know the reason as to why I'm saying it is 0.05, because they didn't highlight on it in the question. So we assume that its level of significance is 0.05. Then with degree of freedom, this is the formula. And I said N1 is for the total number of people in group 1, N2, total number of people in group 2. So you check from the question, it has even been given to you. Or if you can't find it in the question, go through the data And a group 1, they told you we have student number 1 up to 12. So it means it is telling you that the total number of people for group 1 is what? Is 12. Then under group 2, which is female sample, the total number of people, they are what? 10. So it means it will be 12 plus what? Plus 10 minus 2. When you calculate it, will be 20. All right. So you need these 3 information to get something known as the critical value. You need these 3 information to generate critical value. And how do you use these 3 information to get your critical value? During the examination, a formula book will be given to you, which has several tables. Let me stop sharing this. Which has several tables. And one of the tables should have something known as oh, where is it? I can't find it. Okay. Statistical tables. Please, can you see what I've projected? Hello?
No, please.
No, sir.
Okay.
No, sir.
Okay.
No.
Yeah. So we have several tables. When you are doing any t-test, whether it is one sample t-test or independent t-test, or we'll do another t-test, when it is any of them, check within the table, the one they've indicated this, critical values of t. And the critical values of t, you know, I told you we use three key things. We need the degree of freedom, whether the hypothesis is directional or non-directional, and the level of significance. So this is the level of significance. And when you check, they've indicated critical values of t. So it means this table is what you are supposed to use. Then the level of significance, we said it is 0.05. 0.05 is the same as they saying 5%. Then when you see 0.01, when you convert it into percentage, it is 1%. So our focus is 0.01. So it means our level of significance should either be this, we should focus on this side or this side. But for us to know that, okay, this is what we are supposed to use maybe the first one or the second one, it solely depends on this, where they've indicated 2-tailed test or 1-tailed test. And I've been highlighting on this. I said non-directional is the same as 2-tailed hypothesis. Then directional is also known as 1-tailed. So since we know that our hypothesis is non-directional, it means it is 2-tailed. We are supposed to read our information here at the top, which is the 5% here. So it means you are supposed to select this 5%. All right. Then, since we are supposed to select this 5%, you'll be confused. So which of the values should, that means we should pick the values around this side, but we don't know which of the values we are supposed to what? Select. For you to know the value to select, it depends on this degree of freedom. We indicated that the degree of freedom is what? Is 20. So you trace 20 is around this side, then you trace. So it means when you trace, this is the value we are supposed to select. That's 2.086. So that's how you read your information when it comes to the critical value table. So please, if you have a question, please raise up your hand in reading the critical value table. Sorry if I pronounce your name Wrong. Eno Abasi. Please go ahead. Someone's hand is up. I don't know. Sorry if I pronounce your name wrongly.
No, sir, I can hear you.
Okay.
Sir, please, can you go over the whole table? Because I'm confused why you selected the one that had 5% and then the 2.5, but you didn't select the one that had 10% and under it 5%. My main question, is it because it was non-directional that you used the second one?
We use all of them. I told you we have three key things to consider. We're able to consider that we're able to find out that the hypothesis is non-directional. Non-directional is the same as we saying it is what? It is two-tailed. So two-tailed. And we're also able to also deduce that the degree of freedom is 20. That's the degree of freedom. Then the last thing was that we're able to also deduce that the level of significance is 0.05. 0.05 is the same as we saying it is 5%. When you calculate 0.05, that's 0.05 over 100, you get 5%. 0.05 times 100, sorry, you get 5%. So it means per the information we are supposed to use two-tailed, then the degree of freedom should be 20, then the level of significance is 5%. Okay, when you check the table, there's the level of significance where they've indicated significance level. So the 10%, 5%, and so on and so forth, they are all level of significance, but our focus is on the 5% level of significance. And within the table, we have two 5% there. So you'll be in a dilemma. Which one am I supposed to use? And for you to know the one to use, it depends on this side. Two-tailed, they've indicated two-tailed here, two-tailed test. This one is one-tailed test. Then you ask yourself, within the question, my hypothesis, was it two-tailed or one-tailed? And it was two-tailed, so it means two-tailed. And the two-tailed is on top, telling you that you're supposed to pick your level of significance around this side. Sorry, around this side. These are the level of significance you're supposed to pick. And right now we know that the main level of significance you are supposed to select is what? Is the 5% level of significance. And the values on top, the only 5% level of significance is what? Is the second column. So that means that's where you pick your information from, telling you that you're supposed to read your information here, or you're supposed to pick your values at the second column. Then again, you'll be in a dilemma because you have several values under the second column. So which of the values are you supposed to pick? For you to know the value to pick, it solely depends on what? On the degree of freedom here. And we were able to calculate our degree of freedom. We got it to be what? 20. So it means the 20 here for the degree of freedom is telling you that pick your information around this side. So that means you're supposed to select this value, 2.086. That's how you pick, you do it. All right. So right now our value is 2.086. That's our level of significance.
Okay, thank you, Sam.
You're welcome. So right now we know the critical value to be 2.086, which is this. So you can see that I indicated T critical. I brought T because we are doing what? Independent T test. So T test. So T critical is equal to 2.086. So it means within the question, when you are solving, this is the only thing you write. For us to know that your T critical is 2.06, you will tell us that, oh, your level of significance is what? Is 0.05. The statement that I've indicated, I've fused all the three things that I discussed earlier together in a statement form. I'm saying at 0.0 level of, at 0.05 level of significance for a non-directional hypothesis with DF, then I brought the formula and calculated. Then afterwards, I presented the value that I had from the table, which is 2.086. And when you check, I've indicated plus or minus 2.086. The reason as to why we did that was that our hypothesis is non-directional. So we don't know whether it is positive or negative. We don't know whether it is positive or negative. So that's why we have plus or minus there. Okay. So after you are done generating your critical value, you then state this rule. And this is a thumb rule. You retain HO, you indicate we are retaining the null hypothesis if T observed. The T observed is the value that we'll be calculating later. We'll be doing some calculations. And at the end of the calculation, we are supposed to get a value. So that value, we are supposed to compare it with the T critical here, this value that we got from the table. So we are setting a rule that anytime this calculated value, which is T observed, anytime it is less than positive 2.086, we are supposed to retain HO. We are supposed to retain the null hypothesis. But anytime the calculated value, which is T observed, it is greater than or less than 2.086, we have to reject HO. By situations whereby our value is what? Is negative, then our T observed, when it is less than negative 2.086, we have to, sorry, when T observed is greater than negative 2.086, we are supposed to retain HO. And when it is less than or equal to 2.086, we reject. Okay. So please, any question? This is a thumb rule that runs through all the things that we'll be doing. So the first thing is try and find out the critical value. Then you set this rule and make sure that you compare it with the critical value that you generated from the table.
Hello, sir. The rule again, please. You said I didn't get the rule.
The rule is there. I don't know what you want me to repeat again. I've projected everything here so you can see it clearly.
You know, the written, it's faint. We can't get it.
Yes, and I'm saying, Pabla, whatever thing that I was saying, it is on the screen. So I don't know. I was just re-echoing on it. I don't know what else you want me to say.
You just made it bolder now.
Sir.
What?
Yes.
Sir.
Yes, please go ahead. Hello. Oh. Please unmute your mic and speak.
Sir. Hello.
Please go ahead.
Hello.
Regina.
Sir, please, you said that T critic. Yes, you said that T critic is 2.06. Hello.
Regina,
hello.
I don't get your question.
Yeah, I'm asking the question. You said the T critic is 2.086. And the T observed is 2.086. I don't know if there shouldn't be any difference. The observed and the critic. Is there no difference between them? I am not getting that point.
The thing is, decision rule you are supposed to compare your T observed with the T critical. And I said the T observed is the value that we'll be calculating later. And we are saying that when the value is less than that calculated value, T observed, when it is less than 2.086, what do? We have to retain HO. Then when it is greater than or equal to, maybe, so for instance, maybe you calculated a value and you had a value of 4. You have to compare this 4 with 2.086. So this 4 is your T observed. So when this 4, you compare it with 2.086, you could see that it is what? It is greater than 2.086. So it means it is telling you to what? To retain HO. But in situations whereby you calculate the value and you get a value of 1, yet at the same time, you're supposed to calculate this value with 2.086. This value is what? 1 is less than 2.086. So therefore, you have to reject HO. So under decision rule, you are setting a rule that anytime your value is within this area, you are supposed to what? Reject or retain HO. So under non-directional hypothesis, we don't know.
Okay.
Under non-directional hypothesis, we have no idea what our value will be. We don't know whether our value will be positive or negative. So it means you're supposed to state positive and negative decision rules. So the first one that you see here is the positive decision rule. Then the second one that you see here is the negative decision rule. Is the negative decision rule. All right, Emmanuel, please go ahead.
Oh, okay, thank you.
Emmanuel, your hand is up. All right, Emmanuel, please speak. I can't hear you. Okay, kindly unmute your mic and speak.
Anyway, Seb, please can you scroll up? Please keep scrolling. Scroll up. I want to ask a question. You see, no, the decision rule. What the decision rule is? That's what I'm talking about. You said that I was reading the thing, and then it said reject for the which one is it? The no, yes, you said reject. No, yes, reject HO for T is less or equal to 2.086. Is it because of the one that says the males will perform worse in inferential statistics? That's the
No.
I get where you're coming from. With non-directional hypothesis, we don't know whether males perform better or males perform worse. Okay, so in situations whereby they were emphatic, they indicated that males perform better, then it means that our hypothesis will be what? Will be positive, or the value that we'll be getting will be positive. So we would have stated only this positive decision rule, because this T observed, this critical value is what? Is positive. So it means our focus would have been only on this decision rule. But in situations whereby they also said, oh, males perform worse than females, then we would have known that, oh, group 1, their value will be what? Will be negative. Or the value that we will be computing will be negative. So it means the decision rule that we will be stating will be for only this negative decision rule. But here comes the case. Here comes the case with non-directional. We don't know whether the value that we'll be calculating, we don't know whether it will be positive or negative. Hence, we are supposed to state the positive and the negative decision rule. And please pay attention to the signs. When you could see that when it is positive and I retain HO, it is what? It is less than.
Less than.
But when you get to the negative decision rule, it is what? It is greater than. So please pay attention to the signs very well. All right.
Okay, thank you, sir.
You're welcome. So that'll be all. Let me continue because we don't have time on our side. So if you have any clarification, the videos will be uploaded on YouTube. You can go there and watch. So step 4, which is computation. Computation. So under computation, you are supposed to use the formula for independent t-test to solve. And please don't be intimidated when you see this formula. It's very, very simple and everything is systematic. The thing is, I tried to get a symbol for sample mean. I couldn't get. So I just use X to represent sample mean. And you know sample mean, we have a bar on top. So this is what I really wanted to do, but I couldn't get a symbol to represent it in Word. All right. So it means you are supposed to calculate. When it comes to this formula, you shouldn't try to chew it. It will be given to you during an examination. There will be a formula book that has this formula. So it means that we are supposed to calculate the sample mean for group 1, which is the males. Then the sample mean for group 2, which is females. And you know these notations, you know how to calculate them. The 1 and the 2 that you see beneath, don't pay attention to them. It is just telling you that this thing you see here is the same as we saying sigma x squared. The 1 beneath is just telling you that it is for group 1. So you can see that we have the same thing here. And the 2 beneath here is telling you that it is for group 2. So it means you're supposed to find sigma s squared for group 1 and group 2. So anytime you see 1 beneath any of these notations, it means that it is for group 1 or for group 2. Okay. All right. So it means these are the key things we are supposed to calculate. And at this side, you are supposed to find sigma s squared then this value is as saying sigma x. So always don't pay attention to the number below. Sigma x all squared, and you know how to calculate it. So you find sigma x squared for group 1. Then you also find sigma, so this one too is the same as we saying sigma s squared for group 2. Then you also find again sigma x all squared for group 2. And in statistics, when it comes to this course, the moment you see small n, small letter n, it represents sample size. So this n1 is for the total number of people under group 1. That's the total number of males for group 1, which is 12. Then the total number of females, which is what? 10. So that's all. And these things, you know how to solve them. That's the your first the first lecture that we had. We solved these things. So it shouldn't be something that should be what? A bother to you. Hey, I'm trying to reduce it. What is happening? All right. So first, we are supposed to find sigma x. Okay, so I've already done the calculations and all that. So you can see that for group 1, which is males, for males, and okay, so under males, oh, that I'm so under males, you could see that we have what? We have these values, and we are supposed to find sigma x. So under sigma x, you add all the values together. So you add these values together, and when you add them, you will get what 63. That'll be for sigma x for group 1. Then within the
Sir, please, I hardly hear you.
Can you hear me now?
So your voice is gone.
What did you say?
Yes, sir. It's better now, sir. Thank you.
Okay. So per the formula, oh, please try and mute yourself. So per the formula, we are supposed to find sigma x and also sigma x all squared. So when you check sigma x, you need to what? Add the values under group 1, their grades. You need to add them together, and when you add, you get 63. That's what we've done. And you are supposed to find this sigma x squared. Sigma x squared. And you know how to find it. I told you don't pay attention to the numbers beneath. So it means you're supposed to find s squared. And s squared means you're supposed to square the values. 60, 58, you find 60 squared, 58 squared. That's what we've done. After you found them, then what do you do? The next thing for you to do is to add the values together. And we've added. And you do the same thing for group 2. Group 2, you find sigma x. Then you find what? Sigma x squared. So these are the values that we have for group 1 and group 2. Okay. So please, any question? Any question, please?
No questions, so let's move on.
All right. Then I'm moving on.
That's a question. Please, sir, if we have exams, will a table be given to us, or we'll have to create our table them ourselves?
The only table that will be given to you is the one you saw in the question. So it means you have to create columns. If you like to solve x squared, you have to do it yourself. All right.
Oh, thank you.
You're welcome. So I'm moving on. Let me zoom this.
Sir, please, I can't hear you, sir, please.
All right, I hear. And you know the formula for the numerator.
Please, sir, we can't hear you.
Can you hear me now?
It's okay now.
Yes,
Okay. So you know the formula for the we are supposed to find mean for the 2, which is the numerator, the means. You are supposed to find them. And and when you check mean for the 2, you know how to find means. That's sigma x over n. Sigma x over n. And per the question or per our calculation under group 1, we had sigma x to be what? 663. And we know n for group 1, they are 12. So that means your mean for group 1 will be 55.25. Then under mean 2, you had sigma x to be what? 560 over 10, which is for the total number of people under group 2. So it means the mean value for group 2 will be what? Will be 56. All right. This means that your numerator will be what? 55.25 minus 56. Because per the calculation, or per the formula is x1, that's mean 1 minus mean 2. And we know mean 1 to be what? 55.25. Then mean 2 is 56. All right. So that means the numerator will be 55.25 minus 56. And under the computation, sigma x squared, we know sigma x squared to be what? To be 33,080. Let me copy this one and bring it beneath so that we can trace it well. Okay, so let's do it ourselves here. We had mean 1 to be 55.25. Then mean 2, we had it to be 56. Then you go and trace sigma s squared for group 1. Sigma s squared for group 1 is what? Is 37, is 379.2, so, and that's what we've done. 37965. Okay. Good. And here comes the case. We also know per the formula, we also know this one to be what? To be today dear. Let me move all of these to one page so that I think it will help. Yeah. Yep. And so we've been able to solve for this one, which is sigma x squared, and we had it to be what? 37965. That's what you write here. Then you move on to the next one, sigma x all squared. We had sigma x all squared to be what? To be, so it means inside the bracket we have sigma x, which is this 663. So it means 663 what? Squared over n1. n1 is what? 12. That's what you write. Plus sigma x squared for group 2 and sigma s squared for group 2, we had it to be 33080. That's what you indicate here, minus sigma x all squared. So with sigma x, we had it to be 560 for group 2. That's what is here, over 10, which is n2. Then you do the rest. n1 is 12, 10, and so on and so forth. You impute them like that. So when you are done, you do things systematic. Don't rush. First, calculate the numerator. With the numerator, we know it is what? 55.25 minus 56. And when you calculate, you will get what?
Hello, sir.
Yes, Ophelia.
Hello, sir.
Yes.
Yeah, and sir, please, please, how did you get a 3308?
3308. We've already calculated it. That's when we are solving for sigma s squared.
Yeah, also sigma s. Okay, okay.
when we found S squared for females, then afterwards we calculated, we had 33080.
Oh, okay.
So that's what we are using. Okay.
Okay, thank you.
So someone is scribbling on the screen. Please put a halt to this.
Okay, that is S2. I didn't check. It's S2.
All right.
Okay, that's fine.
Okay. So I'm repeating. We'll do things systematically. Don't rush. Solve the numerator, and when you check the numerator, when you subtract, it will be minus 0.75. Then the denominator, the square root is for all the values. When I was doing it, I was having issues. So it's for all the values. So it means take out the fraction first. It means divide 12 by 43956. And when you divide, it will be 36630.75. Then you do the same thing for this side. 313,600 divided by 10, you will get a value of 31360. And you could see that there's a bracket for these values. These main values, we have a bracket. Let me highlight them. Yes, these values. There's a bracket. This is the first bracket and the second bracket. It means that deal with the values within this bracket first. So it means add and subtract them. Then you deal with this one too separately. So when you check this side, there's another bracket here for only for 22 over 120 times 20. So when you multiply 20 by 120, it's 2,400. Then afterwards, you add and subtract these values first, the one in the first bracket. And when you add and subtract, you will get this value, 3054.25. Then you get another bracket here, which is 22 over 2,400. All right. So when you are done, you can what? You can solve the denominator. When you multiply this value, 3054.25, since there are two brackets, it means there's a multiplication sign here. In math, that's how we do it. There's a multiplication sign here. But we don't write it because there are two open brackets. So it means you need to multiply 3054.25 by 22 by 2,400. And when you multiply, this is what you get. A fraction of this. And this fraction, when you check it into decimal, this is the decimal that you get. So when you are done, then afterwards you can square root 27.99, so you can square root it. When you square root, you get this value. Then afterwards, you can what? You can divide 5.291 by what? Minus 0.275. So when you calculate it with your scientific calculator, this is the final value that you get. So this is the main value that we are hoping for. That's our T observed, our computed value. And always your T observed, it's supposed to be in 3 decimal places. So when you move 1, 2, 3, 7 is more than 5. So it means you're supposed to add +1 to this value. So it will be minus 0.142. So that will be our final value that we will get for T observed. So everything should be systematic when it comes to the computation aspect. All right, so please, any question?
So anytime you have a number, you have to round it to 1. If you have it in a decimal form, I mean, sorry.
When you round it, you are supposed to, it should be in 3 decimal places. So for,
Like,
how it's supposed to be in 3 decimal places, it means when it is 5 and above, you're supposed to add 1 to what? To the preceding number.
No, so you're not getting me. I understand that, yes, you have to round it up, but I mean, like, is it like a rule that every answer has to be in 3 decimal places?
Yes, your T observed should be in 3 decimal places.
Okay.
Yeah.
Thank you.
You're welcome. Okay. So that'll be all when it comes to the computation. Is there any other question? All right, then I'm going ahead. Teresa. Teresa, please. I could barely hear you. Hello, Tess. Okay, so I could hardly hear you, so let me continue. So the next one is decision. The next one is decision. With a decision, you are comparing the value, the computed value that you had with your decision rule. So let me copy our decision rule. So this is our main focus when it comes to the decision rule. So with our decision rule, you realize we were what? We were emphasizing on T observed, T observed. Right now we know what the T observed is. And we had a T observed of what? Minus 0.142. So we know that our T observed is negative. So it means our focus should be on what? On the negative decision rule. So it means we would ignore the positive ones and focus on the negative decision rule. And per our decision rule, we indicated that we are supposed to retain HO if our T observed, that's minus 0.142, if it is less than, sorry, if it is greater than minus 2.086. But when our T observed is less than or equal to minus 2.086, we have to reject HO. So then you ask yourself, minus 0.142, is it greater than or less than minus 2.086? So that's my question to the class. Is it greater than or less than?
It's greater than.
Good.
It's greater than.
Yeah. So it is greater than.
It's greater than.
Yeah. So since it is greater than, then it means that we are supposed to what? Select this rule, because per this rule, we indicated that if our T observed, if it is greater than minus 2.086, we have to retain HO. So since minus 0.142 is greater than 2.086, it means you are supposed to retain HO. So under decision, this is how you state it. Comparing your T observed with your T critical, then you indicate, oh, minus 1.142 is greater than minus 2.086. Therefore, you have to what? Retain HO. Because of your decision rule, the way it was stated, it means you're supposed to retain HO. All right. So that'll be all when it comes to decision. So the reason as to why I said it is really, really essential that you get how the positive and the negative, or how to state the decision rule, is that the moment you get your decision rule wrong, especially the signs, if you get it wrong, then it means whatever decision that you make will be wrong. That means whatever decision that you make here will be wrong. And your interpretation would also be wrong. So first, we've been able to make a decision to retain HO. And when you say we are retaining something, it means that we are what? We are maintaining it. Okay. So you move on to step 6, which is interpretation. And our interpretation, for us to interpret anything, it is based on the decision that we've made. Our decision is to retain HO. And you know, hypothesis, we have 2 types. We have null and alternative. And the ultimate is that we want to what? We want to retain one of them. And per our calculations and everything, we've made a decision to retain HO and what? And reject H1. As I said, we have two types of hypothesis, HO, H1. And at the final calculations and everything, we are supposed to maintain one of it. And per our calculations, a decision was made to retain HO. So it means it is HO that we are retaining. So it means we are supposed to interpret what HO is. So since you are retaining HO, you go back to step 2, statement of hypothesis. What did we say for HO? That will be the statement you put under interpretation, because we are retaining HO. But in situations whereby we calculated and our value was what? Was less than, that's the T observed. Had it been less than the critical value, which is minus 2.086, then no matter what, we have no other option than to what? Than to make a decision to reject HO. So it means we would have rejected HO and accepted what? H1. And then state H1 hypothesis, whereby we indicated there is a significant difference. So that would have been our interpretation. But in this regard, when it comes to this calculation, we are supposed to retain HO. So it means that we need to state the HO hypothesis under the interpretation by stating that there is no significant difference. All right. So that will be all when it comes to calculation of independent t-test. So please, any question?
Yes, sir.
All right.
Yes, sir. Please, I would like to ask, when you were comparing the figures, the final figures that we've gotten under the decision, like the way you are narrating it, is there a way that you can also narrate it in words like that, or it's necessary for you to put the figures there?
It's necessary for you to put the figures there.
Yeah, I think like the way you put this in therefore return HO. Is there a way we can put it in words as you explain it before putting the therefore return HO?
Put it like the way I indicated it. That's how you are supposed to do it.
Like you write it in words.
Hey. Any way that you want to do it, so long as it falls within what you want to do. Fine. Yeah.
Okay.
You can do it like that. Like instead of you using the signs like less than, you make it less, you write it less than, right? That's what you want.
Yeah.
Yeah, you can make it in that fashion. Yeah.
Okay.
Okay. So please, any other question?
Hurry up and come and sit down.
All right, Isaac. Mr. Sapon, please unmute your mic.
Yes, sir. I want to ask that if you are answering the question, do you all have to name the steps like the way you named it, step 5, decision interpretation? Do you also have to name it, or you continue to answer it?
No, you shouldn't continue to answer, because every step you'll be marked. And one thing is, you need to know the steps. With the steps, you need to chew it. So step 1 is what? Step 2 is what? You need to know. It should be on your fingertip when you are calculating this. All right. And these steps runs through all the statistical tests that we'll be doing. You follow the same steps. All right. So I tried to get a sample question for you. Okay. And I'll try and share this document on your Sakai platform so that you can have access to it and even try your hands on it. So these are examples of independent t-tests. So let me read. You can see that they are saying children brought up by authoritarian parents during early childhood are less socially adjusted as adolescents than those brought up by authoritative parents, proclaimed a professor of psychology at a seminar presentation. The following data represent the social adjustment scores obtained by groups of adolescents brought up by authoritarian and authoritative parents during early childhood. The social adjustment scores were obtained with an instrument, and scores could range between 10 and 90, with higher scores reflecting better adjustment. Then they've indicated, is the professor's proclamation valid in the light of the above data? So in the first place, let me ask this question. What were they measuring? What were they measuring? Benis.
Attitude, sir.
Sir, please, my own is a question from the various one, but you couldn't see my hand.
Okay, go ahead.
So I wanted to know when the recording will be available, because from the decision place I was a bit confused, but maybe through if I get the radio, the audio fast, the recording fast, maybe I'll be able to catch up.
Yes, it depends. In most situations, sometimes the network is bad at my end. So putting things together and uploading it on YouTube, sometimes it takes a while. But I'm hoping that latest by Monday, it should be ready on what? On YouTube.
So you are going to upload it rather on YouTube?
Yes, that's what I normally do.
Oh, okay.
So I'll forward. Are you on the WhatsApp platform?
Yes, please.
Good. So I'll forward it to your course rep, Isaac. Okay. Then he would I'll forward a link to him so that you can go to YouTube and have access to it. I'll also put the link on Sakai so that anyone who wants to have access could have access and watch.
All right, thank you.
All right.
Please, sir.
Okay.
Sir.
Emma, go ahead.
Yeah, please, sir. We have to get it as soon as possible so that we can prepare well for the exam.
Okay, please.
So
I hear.
It shouldn't be. Okay, thank you very much, sir.
So please, my question. Back to my question. What were they reading?
They are measuring social adjustment. Is that not?
Yes, exactly. They were measuring social adjustment. Then you ask yourself, social adjustment, it is on what scale of measurement? I told you all the psychological constructs, they fall under what? Under interval scale. So social adjustment is a psychological construct. That should tell you that it's an interval scale. And so the second assumption has been satisfied. The first assumption, you could see that we have two independent groups, authoritarian, authoritative, two separate groups altogether. So it means the first assumption has also been satisfied in the question. Hence, you use independent t-test. Okay, and who can tell me the alternative hypothesis in this question? They were comparing two groups, and they said one will be high or low on social adjustment. So who can tell me the alternative hypothesis when you read a question? Oh, hello.
Sir, it is one till.
It is one till. Good. How so? Can you read the alternative hypothesis for me? You are right. It is one till.
Sir, I can't really get the question, but I heard you saying that one group will adjust less because of the less.
Good.
Or is that rather greater than? I just
Good.
wanted that
Good.
side.
Good. So let me zoom this so that you get it well. So you can see that they indicated children brought up by authoritarian. So the first group, authoritarian parents during early childhood are less socially adjusted. You know, social adjustment is what they are measuring, and they are telling you with authoritarian children brought up by authoritarian parents, they are less socially adjusted than those brought up by authoritative. So that's the alternative hypothesis. Then the null hypothesis, you remember I said the moment you see that the alternative hypothesis is directional, it means you're supposed to state two null hypotheses. So the first opposite will be that, oh, authoritarian children brought up by authoritarian parents, they are what? More socially adjusted than those brought up by authoritative. Then the next null hypothesis will be there is no significant difference in social adjustment among children brought up by authoritative and authoritarian parents. That's it. Okay. There's one last question that I want to do. Then that'll be the end. I'll be done with you. So during your spare time, if you like, you can what? You can calculate these things. The next question is an unidentified genetic disease is believed to have reduced the lifespan of members of a certain family until quite recently, when the disease was identified and necessary behavioral intervention measures instituted. The following data represent the lifespans of 11 members of the family before the intervention measures were instituted and 11 other members. So it means this is really critical. Let me repeat that place again. The following data represent the lifespan of 11 members of the family before the intervention measures were.
Sir, please, I can't hear you very well.
Oh. So I'm repeating. The following data represent the lifespans of 11 members of the family before the intervention measures were instituted and 11 other members of the family after the intervention measures were instituted. Then with this, they've indicated at 0.01 level of significance, how effective was the behavioral intervention measures in increasing the lifespan of members of the family. So this is really key. You could see that they indicated they first sampled 11 members of the family before. Then afterwards, they sampled 11 other members, so different members, not the same members. So it means the two members, the two 11 there, they are what? They are entirely different. Because the first one they indicated, they sampled 11 members of the family, and the second one they indicate 11 other members. So it means the two samples there, they are what? They are entirely different from each other. Hence, you are supposed to use independent t-test. And you know what they were really measuring? They were measuring what? Lifespan, years. And when it comes to years, it's on ratio. So hence, you are supposed to use independent t-test. Okay. So that will be all when it comes to independent t-test. If there are no questions, then that will be the end of today's discussions. So any question or clarification when it comes to independent t-test?
Sir, please. I need...
Moses, I could barely hear you. Okay. So please, any question? If you have a question, kindly raise up your hand because I was having a lot of feedbacks. Samuel, please unmute your mic and speak.
Yeah, I really enjoyed your lecture this evening, but
thank you.
Some of us are finding it very difficult understanding the slides, and I hope that at least the lecture will not end anytime soon. We'll have the opportunity to deal with the salient ones, then the rest, because of our busy nature, we can be able to deal with the rest. But in the IA, I noticed that, topics that we didn't deal with, like the what you just taught us this evening, found its way into the IA, and it was actually a take for.
Sorry, someone want to say what I taught you this evening. Which one did you find?
I'm talking about the directional and non-directional experiments you were talking about.
Yes, because it is something I just recorded on it because your lecturer has already talked about it at the beginning. He emphasized on it, maybe because these are the they all fall under the foundations or the fundamentals. Yeah.
So I was only raising that because some of us did not get opportunity to be part of such classes because the communication wasn't that forthcoming. So missed some of the lectures and then relevant material. So it actually made the IA quite cumbersome for us. So that's why we're just drawing attention to that.
Sorry about that. All right.
Hello, sir.
Abeku, Stephen, please,
Hello, sir.
it's your turn.
Yes, sir.
So please, if you have a question, kindly raise up your hand with the emoji. Abeku, so please, it's your turn. Please, I've muted all of you, so Abeku, unmute your mic and speak.
Sir, can you hear me, please?
Yes, I can hear you.
Okay, sir. The question that you just read, you said it's independent t-test, right?
Yes, please.
Okay, so I was thinking, since it was a different sample, couldn't it have been a two-sample t-test?
What is a two-sample t-test? We don't have anything like two-sample t-test, unless maybe you are talking about one sample t.
One sample. Oh, okay. Again, sir, in what way can we have something like that?
They are different from each other. So that's what independent t-test is all about. We have two samples, all right, but they are different. The samples are different. And you could see that definitely one group, they sample one group, then they also sample other members. So the two groups are independent of each other.
Oh, okay, nice. There's another question, please.
Okay.
My link went off. So the question that we were solving first.
Okay.
Yeah, I think I had my link went off, so I didn't conclude with you. I had my final answer to be negative 4.702. Please, is it right?
No, please.
It's wrong.
No, please, it's wrong. Then something went wrong. It's supposed to be minus 0.142.
0.142.
Yeah, minus 0.142. Yeah.
Oh, okay. So then it means we retain, right?
Exactly. You retain HO.
Okay. Oh, okay.
All right.
Thanks.
You're welcome. Okay, so the next person is Emma. Please go ahead.
Okay, sir.
Okay.
Sir, please, what I want to tell you is our slides. The slides, no, if you read it, you don't understand anything. So I apologize to you that you solve more questions so that we get more understanding on, because the slides, say it's something else. Like we don't understand it. There is no example, no calculation. Like it's something else. So this semester, I don't know, but I'm begging you, like you have more time for us so that we can solve more questions.
Emma, the unfortunate thing is, per instructions I've received from distance authorities, I'm supposed to also meet you only 4 times. 4 times throughout. Then the lecturer would meet you 4 times. The lecturer has exhausted his.
So this semester they have to consider.
Currently, I've met you guys 3 times. If I count this one, so it means I have only one last session to meet with you, and that will be
no. They have to consider because we are not in normal time, so they have to consider certain things.
Mr. Thank you, especially with the questions they will say.
They have to do it maybe. Let me stop recording.